Hello everyone. In previous class, we studied some numerical based on dimensional analysis. Today we will discuss some more numerical based on these application. So let us start with first example. In this, it is given that a jet of water of cross-sectional area A and velocity V impinges normally on a stationary flat plate. Means a jet is kept on a plate. Here area of cross section of this jet is A. Here and velocity with which this water comes out is V. The mass per unit volume is rho. It is given that the mass per unit volume of water is rho. By dimensional analysis, determine the expression for force exerted by the jet against the plate. So as we know that from Newton's third law, the force exerted by water means action is equals to reaction. So if you find on which term this force depends, that means on area of cross section, velocity with which water gets out, and the mass per unit volume of the liquid. Here, so here it can be written as this F depends on K is proportionality constant, area of cross section A, let it has a dimension of A here, and A V raised to the power B, and the mass per unit volume, which is also known as density. So mass per unit volume, that is rho raised to the power C. Here, so dimensional formula for force is mLT minus 2 is equals to, put the value of K is equals to 1. So now you can remove it. Area, for area we have L2 raised to the power A, V, that is LT minus 1 raised to the power B, and rho, that is ml minus 3 raised to the power C. Mass upon volume, rho, or you can say density is equals to mass upon volume. Here dimensional formula for mass is m, for volume it is L3. So it can be written as ml minus 3. Here, okay, so m raised to the power c, L raised to the power 2a plus b minus 3c, and t raised to the power minus b. So this can be written as m1 L1 t minus 2. So on comparing we get, so c is equals to 1. Here m has a dimension of c, in LHS side m has a dimension of 1. So on comparing, c is equals to 1. Next, 2a plus b minus 3c is equals to 1. Here length has a dimension of 1. In third part, minus b is equals to, here it is minus 2. So b is equals to 2. Now put the value of b and c in this equation. So 2a plus value of b is 2 minus 3 into 1 is equals to 1, or 2a plus 2 minus 3 is equals to 1. So this becomes minus 1. So 2a is equals to 1 plus 1, or a is equals to 2 by 2 is equals to 1, or a is equals to 1. Clear? Now put the value of A, B and C in equation 1. In equation 1, we get F is equals to value of small a is 1. So a 1. Here V raised to the power b. Value of b is 2 and rho to the power c. So rho 1. This can be written as F K A V square rho. Here, so this is the formula for force that, or you can say this is the value of force which exerted by the jet against the plate. Clear? Next numerical. Next numerical, the frequency of the oscillating drop depends on the radius of the drop, density of the liquid, density rho of the liquid, radius r, density of the liquid, and density rho of the liquid and surface tension S of the liquid. Frequency mu, surface tension of the liquid. So with the help of dimensional analysis, derive a relationship for frequency nu. So here this frequency nu can be written as K, that is proportionality constant, radius, so R raised to the power A, density, that is rho raised to the power B, and surface tension S raised to the power C. So surface tension can be written as force upon length. We know that the dimensional formula for force is mLT minus 2 upon dimensional formula for length is L. So this can be written as mt minus 2. Clear? So, and for rho, that is density, is equals to mass upon volume. For mass and for volume L3. So ml minus 3. Clear? Put K equals to 1. So this becomes, and frequency is equals to 1 upon time period. So this can be written as t minus 1. So t minus 1 is equals to, okay, r raised to power a. R is radius. So we have the dimension formula L raised to power a. For density we have ml minus 3 raised to power b. For surface tension we have mt minus 2 raised to power c. This can be written as m0 L0 t minus 1. Here m raised to power b plus c L raised to power a minus 3b, clear, and t raised to power minus 2c, clear. On comparing we get mb plus c. So b plus c, here mass has a dimension of b plus c, and this side it is 0. So 0. So b is equals to minus c. A minus 3b is equals to 0. So a minus 3b is equals to 0. In third part we have minus 2c is equals to 1. So minus 2c is equals to 1. Sorry, minus 1. Minus 1. Cancel out. So c is equals to 1 by 2. Put this value over here. So b is equals to again minus 1 by 2. Now put this value of b in this equation. So a is equals to 3b, or 3 into minus 1 by 2, or minus 3 by 2, value of a. Now put the value of a, b and c in equation 1. So put the value of a, b and c in equation 1. So nu can be written as k r raised to power a. Value of a is minus 3 by 2. So r raised to power minus 3 by 2. Here the rho raised to power b, and value of b is minus 1 by 2. So rho raised to power minus 1 by 2. And surface tension s raised to power c. So s raised to power c, and value of c is 1 by 2. So this can be written as k s raised to power 1 by 2 upon rho raised to power 1 by 2 s raised to power 3 by r raised to power 3 by 2, or you can say k under root s upon rho. Here 3 by 2 can be written as 1 into 1 by 3 into 1 by 2. So for 1 by 2 we took the square root, and this will become r cube. So this is the expression for frequency in terms of surface tension, density and radius. Yes. So the next example, next question. If force, velocity and time is taken as fundamental quantity then find the dimensional formula for work. Clear? So here it is given that we have fundamental quantity force, velocity and time. That means this work can be written as K, that is proportionality constant, force raised to the power A, velocity raised to the power B, and time T raised to the power C. Clear? We know that the dimensional formula for work, that is work can be written as force into displacement. So for force we have mLT minus 2 into, for displacement we have L, so this can be written as mL2 T minus 2. So mL2 T minus 2 is equals to K, or you can say put K equals to 1. So for force we have mLT minus 2, here it is given raised to power A. For velocity we have LT minus 1 raised to power B, and for time we have T raised to power C. So m raised to power A, L raised to power A plus B, T raised to power minus 2A minus B plus C. Clear? So M1 L2 T minus 2. On comparing, we get m raised to the power A, here m raised to the power 1. So A is equals to 1. L raised to the power A plus B, here it is 2. So A plus B is equals to 2. Put the value of A over here. So B is equals to 2 minus A, or it can be written as 2 minus 1 or 1. So value of B is 1. Third, T raised to the power minus 2A minus B plus C is equals to minus 2. Clear? So minus 2 into 1 minus value of B is 1, minus 1 plus C is equals to minus 2, or minus 2 minus 1 minus 3 plus C is equals to minus 2, or C is equals to minus 2 plus 3, or C is equals to 1. Clear? So put the value of A, B and C in equation 1. In equation 1, we get what, that is W is equals to K F raised to the power A, value of A is 1. So F. V raised to the power B, so value of B is again 1. So V. And T raised to the power C, again it is 1. So T. So W can be written as F V T. From here we can check force can be written as mLT minus 2, clear? And for this LT minus 1, so TT cancel, so M, okay. So mL2 T minus 2, clear? In next class, we will discuss some next part of this fundamental analysis. Thank you.